Welcome to Study Loop.
Now we know that I is equal to I naught sine square n phi by 2 by n phi by 2 squared. I'm sorry, sine square phi by 2. Now for part A, we want to see what happens when phi tends to 0. So for limit phi tends to 0, sine square n phi by 2 by sine square phi by 2. Notice that both the numerator and the denominator go to 0, which means we can use the L'Hopital's rule and differentiate both sides, both the numerator and denominator. The differential of the numerator gives 2 sine n phi by 2 cos n phi by 2 into n by 2. And the derivative of the denominator with respect to phi gives 2 sine phi by 2 cos phi by 2 1 by 2. Now, by cancelling a few terms, we can see that these two terms are 1 because phi is 0, and these two terms again go to 0. So but we know that when limit phi tends to 0, sine phi is equal to phi, and which means sine n phi must be equal to n phi. Or we can simply use L'Hopital's rule again for these two terms and see that it gives you another n, giving us n squared. So I limit phi tends to 0, I is equal to n square I naught. Now, for part B, well, the maxima occurs at phi is equal to 0. Where do the first minima happen? So obviously for the minima, we want sine square n phi by 2 by sine square phi by 2 is equal to 0, which means the numerator has to be 0, which means sine n phi by 2 is equal to 0. This happens when n phi by 2 is equal to plus or minus pi. This happens at plus pi and this happens at minus pi, giving us phi is equal to plus or minus 2 pi by n. Hence, this width is equal to 4 pi by n, which is inversely proportional to n. Now for part C, we want to see that when phi is equal to when there are minimas, which means the minimas happen when sine n phi by 2 is equal to 0, which means n phi by 2 is equal to n pi, where n is an integer, which gives us phi is equal to 2n pi by n. So for all these values, sine n phi by 2 is 0, hence it must be minima. But notice that the expression we have is I naught sine n phi by 2 by sine phi by 2 squared. So if sine phi by 2 is 0, that is the denominator is 0, then we'll have to, it's fishy. We need to take care of it. The denominator will be 0 when phi by 2 is equal to n pi, which means phi is equal to 2n pi. So all the multiples of 2 pi by n, except for those that are multiples of 2 pi, give a minima. What about the multiples of 2 pi? That is when phi is equal to 2n pi. We just saw that these give you a maxima. We can see that by simply doing the L'Hopital's rule and seeing that I will be equal to when both the numerator and denominator are 0, we'll see that I is equal to I naught n squared. Now, for the fourth part, which is D, well, we know that phi is equal to 2n pi by n, except for those that are of the form 2n pi. So let's take a case and count. For n is equal to 0, we have 0. Then we have 2 pi by n, 4 pi by n, so on until 2n pi by n, which will be 2 pi. Now these two are minimas. I'm sorry, these two are maximas, and the number of if we count the number of points in between these two, those will be the minimas. They go from 2, 4, all the way to 2 into n minus 1. So these are totally n minus 1 minimas in between any two maximas. And for part E, we know that n pi and n plus 1 pi are where minimas happen. I'm sorry, beta equal to 2n pi and 2n plus 1 pi are where minimas happen. So these are the values of beta, which means beta by 2 must be n pi and n plus 1 pi by 2. So the mid value between them will be the average, that is 2n plus 1 pi by 2. I'm sorry, there is no 2 here. Now, at this value, we know that the intensity will be I naught times sine 2n plus 1 n pi by 2 divided by sine 2n plus 1 pi by 2 whole square. Now, the denominator is obviously plus or minus 1, but the numerator, if n is even, will be 0, and if n is odd, will be 1. So for when n is even, I will be 0, and when n is odd, I will be simply I naught. Hence, at the midpoint between two maximas, the intensity can't be more than I naught.